SK015.
Alright, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Okay guys, in this video you're going to watch the demonstration video on experiment 5 chemical equilibrium.
The experiment is about chemical equilibrium, specifically focused on Le Chatelier principle. Le Chatelier principle states that if a dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium shifts to re-establish an equilibrium. Thus, in this experiment, you will see the effect of concentration and temperature towards chemical equilibrium. Let's start with part A of experiment, which is the effect of concentration. In this experiment, the thiocyano-iron 3 complex ion is formed when iron 3 ion is added to thiocyanate ion. Thus, the equilibrium between these three ions will form. To prepare the solution, first mix 2 ml of 0.1 molar iron nitrate and 3 ml of 0.1 molar sodium thiocyanate in 100 ml beaker. Then, add 50 ml of distilled water. Measure all the solution by using measuring cylinder. After mix the two solution, red blood solution will form. Transfer 5 ml of the red blood solution into 4 test tubes and labeling the test tube A, B, C and D respectively. For test tube A, add 1 ml of 0.1 molar iron nitrate. This means in the test tube A, the concentration of iron nitrate has been increased, and you can see the effect of increased concentration of iron nitrate towards the chemical equilibrium. Record the observation. You can compare the color of solution with test tube D, as test tube D is served as control. So, for test tube A now, you can see the observation is the intensity of the red blood solution are increased or red blood solution become darker. Repeat the same procedure for test tube B and C, but this time add 1 ml of 0.1 molar sodium thiocyanate to test tube B and 5 to 6 drop of 2.5 molar sodium hydroxide to test tube C. From the observation, you can discuss the effect of concentration towards the chemical equilibrium. Now, we move to part B of the experiment, which is the effect of temperature. In this experiment, the reaction between hexa-aqua-cobalt-2 complex ion with chloride ion produce tetrachlorocobalt-2 ion will be carried out. To prepare the solution, first mix 2 ml of 0.2 molar cobalt chloride and 20 ml of 6 molar hydrochloric acid in 250 ml conical flux. Then swirl the flux. Supposedly, the purple solution will be formed. Divide the purple solution into 3 test tubes and label the test tube A, B and C. For test tube A, leave the test tube at room temperature. For test tube B, place the test tube in the ice bath. For test tube C, place the test tube in a water bath at 80 to 90 degrees Celsius. Leave the test tube for a while at respective temperature. Observe which test tube experience change in color. Record the observation. After that, remove test tube B and C from ice bath and water bath, respectively. Then leave these two test tubes at room temperature. Record again the observation for test tube B and C at room temperature. From all these observations, you can discuss the effect of temperature towards the chemical equilibrium. For part C of this experiment, you will determine the equilibrium constant for the chemical equilibrium given. First, pipette 5 ml of 0.5 molar antimony trichloride in 6 molar hydrochloric acid into 100 ml conical flux. Fill the burette with distilled water. Record the initial reading of burette. Put black sugar pepper on the bottom of conical flux in the titration setup. Then, titrate the solution in the conical flux with distilled water. Stop the addition of distilled water when white precipitate form, which indicate the reaction has reached equilibrium. Then, record the final reading of burette. From the initial and final reading of burette, you can calculate the volume of distilled water used. Then, you can calculate the concentration of antimony trichloride and hydrochloric acid at equilibrium. From this concentration, you can determine the equilibrium constant of the reaction.